Hi friends, welcome back to EMRS Nasik. Today we are going to start a new chapter called Determinants, and this is our first lecture. And in this lecture we are going to see what do we mean by determinants and how to find the determinants of order 1 by 1, 2 by 2 and determinant of order 3 by 3. Now suppose we are given a square matrix Aij and this square matrix is of order n, then we can associate a number to a given square matrix and that number is called determinant of a matrix. Now we know that a matrix is the arrangement of numbers, and we have seen that numbers may be real or complex, but the determinant is a number. It is a number associated to a square matrix. So matrix is the arrangement of numbers, whereas determinant is a number which is associated with that square matrix. Okay, so matrix is a arrangement whereas determinant is a number, and determinant of a square matrix A, it is denoted by determinant of A. Do not read this as a modulus of A. Okay, we are in determinants, that means read this as determinant of matrix A. Now we will see how to find the determinant of matrix. Okay, now another note is there, only square matrices have determinants. If you are having a rectangular matrix of order suppose 2 by 3, then you cannot find the determinant of that matrix, because the determinants can be calculated for the square matrices only. Now we will see how to find determinant of order 1 by 1. Suppose you are given a square matrix A which is of order 1, then the determinant of this matrix A is equal to simply that number A which is inside the matrix. Okay, that means simply A. For example, suppose we are having a square matrix of order 1 by 1. Now the determinant of this matrix A is simply the number 2. Okay, now suppose again I am having another matrix of order 1 by 1. Then determinant of this matrix B is simply the number inside the matrix, that is minus 5. Okay, so determinant of matrix B is minus 5. Now we will see how to find a determinant of order 2 by 2. Suppose you are given a 2 by 2 square matrix like this, A is equal to square matrix of order 2 by 2, then determinant of this matrix A is equal to, we will write this as determinant of matrix A is equal to, we will write these elements in determinant. So now how to find this? So in order to find the determinant of this matrix, just take cross multiplication, means take multiplication of A and D and subtract this multiplication. Okay, that means what will be the determinant? AD, A into D minus B into C. Okay, so this is the method to find the determinant of order 2 by 2. Now we will see how to find the determinant of order 3 by 3. Now suppose we are given a square matrix of order 3 by 3. Then determinant of A is equal to, we will write all these elements in determinant. So now how to find the determinant of order 3 by 3? There are 6 different ways to find the determinant of order 3 by 3. Now which are the 6 ways we will see. We can expand this determinant along first row or second row or third row, or we can expand the determinant along first column or second column or third column. So these are the 6 ways to evaluate the determinant of order 3 by 3. Now we will see some of them. Suppose this is our determinant of order 3 by 3. Now in order to find the determinant, just remember one sign convention. And what is that sign convention? See. So this is the determinant of order 3 by 3. Just remember these signs. Along first row we are having plus, minus, plus. Along second row we are having minus, plus, minus, and along third row we are having plus, minus, plus. Now if you want to expand this determinant along first row, so what are the sign conventions for first row? Plus, minus, plus. Okay, so now we will expand this determinant along first row. So the determinant will be this equal to, now first element is what? First element sign will be what? Plus. So this will be plus this element, okay, plus this element. And now remove this row and this column. That means if you want to expand the determinant along first row, then take this first element as plus A11 and remove first row and first column. So what you left with? First write down this element A11 and remove this first row and first column. You left with A22, A23, A32, A33. Just I have written this. Okay, now you are expanding this along first row. That means what is the second element? A12. And what is the sign of A12? A12 is negative here. Okay, A12 is negative. So I will erase this. Now A12 will be what? So A12 will be this element, and the sign convention is negative, means this element will be negative A12. A12 means remove first row and this second means second column. Now what you left with? A21, A23, A31 and A33. So what will be the sign of A12? Since sign convention is negative, so this will be negative A12, and the determinant of A21, A23, A31 and A3. Now similarly the third element can be written as, how will you write third element? I will erase this. Sign convention for third element is plus, so this will be plus, this will be plus A13. Now what you will delete? You will delete first row and third column. So this will be the determinant of A21, A22, A31 and A32. Now we know how to find the determinants of order 2 by 2. So lastly I will write this as determinant of A is equal to A11, and this will be cross multiplication A22 and A33 minus A32 and A23. Similarly this will be okay, and third element will be A13 into this determinant. So this is the method to find the determinant of order 3 by 3. Similarly you can expand this along row 2. The same determinant is there, sign conventions remember. Now we will expand this along row 2. So this determinant is equal to, now the sign convention for second row is minus, so this element will be minus A21, and what you will do, you will remove second row and first column. Okay, so this will be minus A21. Okay, this A21 because sign convention is minus, and you left with the determinant A12, A13, A32 and A33. Similarly second element is what? Second element is positive. So what you will do, you will remove second row and second column. So second row and second column. So this will give me sign convention for second element is plus. So A1, what you left with, determinant A11, A13, A31 and A33. Similarly for third element you can write. So after evaluating you will get this answer. Now these are the two ways. Similarly you can expand the determinant along R3 also. So do it on your own by using this method. But now we are going to expand this determinant along C1. Okay, so we are going to expand the determinant along C1. Now if you see C1 first column, what are the sign conventions? C, plus, minus and plus. So first this element will be plus A11, and afterwards what you will do, you will eliminate first row and first column. So this will be plus A11, and you left with what? The determinant A22, A23, A32 and A33. Similarly second element is what? Minus. Second element is minus. So minus of what? Minus of this A21, because we are expanding along column C1. So since you are expanding along C1, so what you will do, you will eliminate second row and first column. Okay, second row and first column. After eliminating, what you will get? Second row and first column. You left with A12, A13 and A32, A33. So take determinant, but the sign convention for first row second element is first column, second element is minus, so this will be A21. Similarly for third element, this is A31. Okay, and this is plus sign, and remove third row and first column. So after evaluating this, you will get the determinant value. Similarly you can expand the determinant along C2 also. Okay, so by considering the sign conventions minus, plus, minus, you can evaluate in a similar way. So this is the determinant of order 3 by 3. So note one thing, expand the determinant along a row or column which contains maximum number of zeros. So what will happen, the calculations will be easier because zeros, maximum numbers of zeros will reduce your calculations. So in this way you can find the determinant of a square matrix of order 3 by 3 in how many ways? In 6 ways. Okay, so either you can expand the determinant along R1, R2, R3, or you can expand the determinant along C1, C2, or C3. In all the cases you will find the same determinant value, means the value will not change. By any one of the method, the value of determinant remains the same. Okay, thank you and have a nice day.